Quadratic modeling area problems. In this type of problem, we're going to build rectangular pens. We're going to have a certain amount of fencing and use the side of a barn or a stone wall or some other already pre-existing wall for the fourth side. But before we do that, let's go for a helicopter ride. Oh, wow. Why, looky here. Here we are hovering right over Lawrence Academy. I didn't know that from the air you could see all those labels. Let's zoom in on the Gibbet Hill Grill. It used to be a barn, and that's the barn on which we're going to build our rectangular cow pen. Come on, we can get closer. Come back, my picture. You are getting tiring. Little Google Maps is a little slow. Here's the barn. That's as close as I can zoom in on the barn. Maybe I can move over a little bit. Let's see what happens. Sure. And over here, on to the right of the barn, we want to add a cow pen. I'm sure that will be very attractive to the dancers and the wedding moon and the honeymoon parties we have here. So here, we only need to put fencing on 3 sides, not on 4, because we're going to use the edge of the barn as one of the sides. And so when we set this up, we have to choose one of the sides to be our variable. Well, this would be the width. This would be the length. This would also be the width. So one of them to be a variable. But suppose I have 100 meters of fence. What length and what width would maximize the area? Now, I don't want 2 variables. I'm going to have 1 variable. I'll just call the width equal to x, and the length is going to equal 100 minus 2x. So that's what I'm going to work with for an equation. And the area is length times width. So it's going to be x times 100 minus 2x. Hey, look at that. There's our old familiar quadratic equation. Oh, let's think about that for a minute. If it's a quadratic equation, it'll be modeled in a parabolic curve. The vertex will give us the maximum. And it will be symmetrical about the 2 zeros. So where are the zeros? Since this is in factored form, x equals 0 is one of the zeros. And 100 minus 2x equals 0 will give us the other 0, or x is equal to 50. 50. 0. 50. Based on the symmetry, the x-coordinate of the vertex would have to be 25. 25. Oh, let's plug that into the equation. 25 times 100 minus 2 times 25. 25 times 100 minus 50. Okay, I think I'm going to be able to figure this out. Make sure I got the right number of parentheses. 25 times 50. That equals 1,250. Now let's see. I've left out the units of length, but this was meters, and that was meters, and this is meters. So this is meters times meters, or meters squared. So we know the area is 1,250 square meters, but what are the dimensions? Well, we had figured it out earlier, that x, the width, was equal to 25. That's true at the top. That's true at the bottom. The length, then, is 100 minus 2 times 25, or the length is 50. These, again, of course, in the unit of measure that we've chosen, are all in meters. Oh boy, what a crash landing of that helicopter. I hope you're okay. I hope you didn't get hurt coming back to here. But let's just take this problem a little bit farther. Here's the barn at Gibbet Hill. What we did earlier was create a single pen. But what if we wanted to create 3 pens, all rectangular, built off the side of the barn? And so now I have 3 pens. It's really the same problem, just be careful. X, 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 X. So what's the length now? It's not 100 minus X, but it would be 100 minus 4X. 100 minus 4X. And the area we're trying to maximize would be given by the expression X times 100 minus 4X. Your job is to finish this problem and tell me what is the length and width of each individual pen and what is the maximum area of each individual pen. Ciao for now.